Welcome back to the deep dive. We're going deep on this paper on model inversion attacks in machine learning. And I know you're like an expert in this, so let's just skip the 101, right?
Right.
We'll go straight to the good stuff.
Yeah.
How confidence values can be used to reveal sensitive data.
Yeah, it's pretty amazing how these attacks can pull out sensitive information from models that, on the surface, you wouldn't think they could, trained on things like lifestyle surveys or even facial recognition data.
It's building on stuff that has already been done, right?
Yeah.
Like the Fredrikson work.
Yeah, so Fredrikson's work primarily focused on cases where the sensitive feature has a limited number of possible values, right? And this paper is kind of tackling the challenge of how do we invert models where the sensitive feature can have like a much larger range of possibilities, like the types of things you would see in like a real world data set.
So they use Big ML,
Right.
which is a platform where people share machine learning models, right?
Right.
To test these attacks out.
Exactly. Yeah, and specifically they focus on decision trees,
Right.
which are generally considered to be like relatively transparent, easy to interpret. But even in this context, they're able to show some pretty surprising results.
And they looked at two data sets, right?
Yeah.
From 538, How Americans Like Their Steak,
Right.
and the General Social Survey,
Yeah.
GSS,
Exactly.
both have potentially sensitive information.
That's right, yeah. So the stake survey asks questions about, infidelity. And then the GSS data set, they're looking at questions related to, like, viewing habits.
And they looked at both black box and white box attacks.
Yeah.
Which is pretty standard, I would say, for this type of research.
Yes, yeah.
So the black box attacks are, treating the model as a complete mystery box where you can only just, input data and see what the output is.
Right.
White box, you can actually see inside.
You have full visibility.
You can see how things work.
Yeah.
So for the black box, they used the generic model inversion algorithm from Fredrikson, and they adapted it to decision trees.
Yeah, and it worked reasonably well. It outperformed random guessing, but it did have a fairly high false positive rate.
Oh, wait.
So, for example, in the GSS data set, it concluded that a person had watched adult videos in the past year almost 60% of the time.
Wow.
Even when they hadn't.
That's pretty high. And then for the white box, they introduced something called white box with counts, or the WBWC estimator.
Right.
Which uses more information because it's a white box.
Exactly, yeah. So, in a white box setting, you have access to things like the number of training instances that match each path in the tree. And Big ML actually provides all of that. So their white box mode is very, very white box. And so they use that information to define this this estimator. And it ends up performing much better, or I should say, from an attacker's perspective, much better. Right? It has perfect precision when it comes to identifying, or I should say predicting, positive instances of the sensitive feature when they're targeting individuals who are actually present in the training data.
That's scary.
Yeah, and so this really highlights that if your data is in one of these training sets, you're at considerable risk.
Right.
Now, when they target individuals who are not in the training data, then the precision is much, much lower.
Oh, okay.
Right. So that's kind of an interesting question, is like, what is it about these individuals who are in the training data that makes them so vulnerable?
Right.
And computationally, are they like very resource intensive, or are they quick and easy to do? They're both very efficient. You can run them very quickly. And so I think, one of the takeaways from this is that, in terms of like precision and recall, precision is the of all the predictions that you make that are positive, how many of those are actually correct? So the white box attack has perfect precision, but the recall is not perfect.
Right.
Meaning that it doesn't necessarily identify all of the instances of the sensitive feature. But from a privacy perspective, the fact that the precision is so high is quite concerning.
Right, because it's like a needle in a haystack.
Yeah.
If you find the needle, it's the right needle.
Exactly, yeah.
But you might not find all the needles.
Right.
But if you're only looking for one particular needle and you find it, you're good to go.
Right.
And to illustrate the point, the white box attack achieved a 593x improvement in precision and 371x improvement in recall on the 538 data set.
Yeah.
Compared to just random guessing.
Right.
Which is, it's a huge jump in performance.
It is, yeah.
Really solidifies the idea that, okay, if you're in the data set that the model was trained on, you were really at risk.
Right.
But they didn't just stop at decision trees.
Right.
They went to facial recognition as well.
Yeah, so facial recognition is kind of a whole other beast.
Right.
We're not talking about categorical data. We're talking about very high dimensional data, like pixel values in images. And so, being able to invert these models to actually reconstruct, recognizable faces is a very challenging task.
You want to know how they did it.
Right. And so what they realized was that many facial recognition APIs, even in the black box setting, they often reveal confidence values, right, along with the predicted label.
Right.
So they'll tell you, okay, we think this is this person and we're 80% confident or 90% confident or whatever. And so they realized that you can actually leverage those confidence values to essentially reverse engineer the process.
Okay. So they use those confidence scores to reverse engineer the model's decision.
Exactly.
Okay.
And so the way they formulated this problem is basically as an optimization problem.
Okay.
Right.
Halfway.
Find the input image that maximizes the confidence of the model.
Okay. So find the image that makes the model really think it's that person.
Exactly.
With high confidence.
And they call that the reconstruction attack.
Okay.
Right.
And so how do they do that?
So they basically employ a gradient descent-based algorithm that's specifically tailored to the image domain. So what they do is they essentially start with some initial image, and then they iteratively adjust the pixel values of that image in a way that guides the model to produce the desired output, right? With high confidence. And it turns out this actually works remarkably well. And it's also very efficient. They're able to complete these reconstructions in a matter of, seconds or minutes, even for, more complex models.
Yeah. Oh, wow.
So it's quick.
It is, yeah. It's not like some, days-long process or something.
Right. And so, but of course, when you're talking about images, it's not enough to just look at, numerical metrics.
Right.
You actually want to see if these images are recognizable.
Right.
So what they did was they used Mechanical Turk, which is this crowdsourcing platform, to assess the recognizability of these reconstructed faces.
Oh, so they had humans look at it and be like, yeah, that's the person. Or, no, that's not the person.
Exactly, yeah. So they would show them, a set of images, and they would say, okay, which one of these is, this target individual? And the results actually varied depending on what type of facial recognition model they were targeting.
Oh, really?
So interestingly, the simplest model, which is like a softmax classifier, actually produced the most recognizable images. So they got 75% overall accuracy and 87% identification rate, which is, significantly better than chance.
So even with a simple model, you can get a pretty good picture of someone's face.
You can, yeah.
So, that seems like that has huge implications for, anyone who uses facial recognition, which is a lot of people, a lot of institutions.
It does, yeah. And it really kind of highlights the vulnerability of these systems. And the potential for misuse. So
they didn't just stop there.
Right.
They went on and looked at some potential countermeasures.
Yeah, and so this is just kind of a preliminary exploration.
Right.
They're not claiming to have, solved the problem, but they wanted to, provide some initial insights into what might be possible.
Yeah.
So for the decision trees, they focused on the placement of the sensitive feature in the tree. So basically, how deep in the tree is the sensitive feature?
Right.
And their hypothesis was that, well, if you could somehow move that sensitive feature around, you might be able to, influence how effective the attack is.
Oh, like hide it deeper in the tree.
Exactly, yeah. And what they found was that it's not a monotone relationship.
Right.
So sometimes moving the sensitive feature actually made the attack harder. Sometimes it made the attack easier.
Oh, that's interesting.
Right. So it's not as simple as just saying, okay, let's bury it as deep as possible.
Right.
There might be some optimal placements for these features that, provide, better privacy without necessarily sacrificing too much accuracy.
That's cool.
Yeah.
What about for the facial recognition?
So for facial recognition, they focused on the black box setting.
Okay.
And what they looked at was the impact of reducing the precision of the reported confidence values.
Oh, so just being less precise with the numbers you're outputting.
Exactly, yeah. So they said, okay, what if instead of reporting, 87.3% confidence, we just round that to, 87%?
Okay.
Right? Or what if we round it even further to, 90%? And what they found was that even, modest levels of rounding can significantly degrade the performance of the attack.
Really?
Yeah.
Wow, that's so interesting that even that small change can actually make a difference.
Yeah, it's quite surprising. And
Yeah.
it suggests that, even relatively simple techniques can be quite effective at, bolstering privacy.
Right, without having to, completely rewrite the entire machine learning algorithm.
Exactly, yeah.
Some small tweaks can actually make a big
Oh, yeah.
difference.
Right.
This is really interesting stuff. It really highlights the fact that we have to go beyond just accuracy in our models
Yeah.
and think about, okay, what are the potential privacy risks?
Absolutely. It really kind of throws open some fundamental questions about, like, the future of machine learning and data privacy.
It definitely seems to challenge the assumption that just because a model isn't like directly outputting raw data,
Right.
that it's somehow safe.
Right. Yeah.
We've seen how these inversion attacks can exploit even like seemingly insignificant information leaks,
Yeah.
like those confidence scores to reveal sensitive information.
Exactly. Yeah, it's kind of a ripple effect, right? If you kind of connect this to the bigger picture and you think about the fact that, machine learning models are becoming increasingly available,
Right.
you know, through things like Big ML, through open source platforms.
Right.
And so it's becoming much easier for individuals to access and use these models, which is great for innovation, right? But it also potentially kind of amplifies these privacy risks.
It's a double-edged sword.
Yeah.
Where we're democratizing access to these powerful
Right.
tools, but we're not necessarily democratizing the understanding that
Exactly.
has downsides.
Yeah, it's like giving someone a high-powered sports car without also giving them, driver's ed.
Right.
Right.
And this paper is a little bit of a wake-up call, I think.
Yeah.
Yeah. In that sense, it's not just, showcasing the vulnerabilities, but also encouraging the community to be like, hey, let's address this.
Yeah, I completely agree. And I think the fact that, the authors dedicate a significant portion of this paper to actually exploring countermeasures is very commendable.
Right.
It shows that they're not just trying to highlight the problem, they're also actively searching for solutions.
And that's where the value is, I think.
Right.
Not just showcasing, oh, this is broken, but like, okay, what can we do about it?
Exactly. Yeah, we need more research on, how do we actually develop robust defenses against these types of attacks?
Right.
Right. Whether it's through, the model training process itself or, the way we handle the data or, carefully designed ways of obfuscating the output.
Right.
I think it's a multifaceted challenge that requires a multifaceted approach.
And I think also, aside from the technical stuff,
Right.
there's like the ethical and legal considerations
Yeah.
too, right?
Mm.
Like how do we inform users about these risks?
Yeah.
How do we balance the benefits of machine learning with the need to protect privacy? Those are questions that we should be asking ourselves.
Yeah, I mean, you can't just focus on the technical aspects, right? You have to engage with the broader societal implications as well.
Right.
And, the potential for misuse is vast, especially as these models become increasingly integrated into, sensitive areas like healthcare and finance and social interaction.
Like facial recognition.
Exactly.
It's already, a contentious technology
Right.
with concerns about surveillance and privacy. And now imagine if those systems become vulnerable to these kinds of attacks where someone can reconstruct your face
Right.
just from your name.
Yeah, that's a sobering thought.
It is.
And it really kind of highlights the need for proactive measures, right? Like, we can't just wait for these problems to arise and then react.
Right.
We need to anticipate these potential issues and kind of build in safeguards from the outset.
So for our listener who's a fellow researcher in this field,
Yeah.
what are the big takeaways? What are the things they should be thinking about as they go forward with their own work?
Well, I think first and foremost, this paper is a pertinent reminder that model inversion attacks are a real and present threat, right? They're not just, theoretical curiosities.
Right.
They can be executed in practice and they can be surprisingly effective at extracting sensitive information
Right.
from seemingly protected models.
We can't be complacent.
Right.
Just because it doesn't explicitly say what the data was doesn't mean it's safe.
Exactly. And we need to be vigilant about identifying potential vulnerabilities, right? Even those that seem subtle or insignificant.
Right.
Like, because as we've seen, those confidence scores, they seem very innocuous.
Right.
But they can actually be a gateway for attackers.
So the little things.
Yeah. And I think the paper also kind of underscores, the heightened risk that's faced by individuals whose data is actually part of the training set.
Mhm.
Right. And so I think this raises some really important questions about, data privacy informed consent.
Right.
The effectiveness of anonymization techniques.
Right.
And we need to ensure that, the individuals who contribute to these data sets are adequately protected.
It's about responsibility.
It is, yeah. Both for the researchers who collect and use these data sets,
Right.
and for the institutions that oversee their use.
Right.
And I think, perhaps the most encouraging takeaway is that countermeasures are possible.
Right.
Right? This is not a hopeless situation.
Right.
We can develop techniques to mitigate these risks, to make our models, more robust, more privacy preserving.
The call to action.
It is, yeah.
To the community to be like, hey, let's prioritize these techniques alongside our traditional, metrics for accuracy and efficiency.
Right. We can't just be chasing performance at the expense of privacy.
Right.
Right. It's about finding that balance between pushing the boundaries of what's possible with machine learning, but also ensuring that we're doing so responsibly and ethically.
One thing that I thought was really interesting about this paper was their use of Mechanical Turk.
Oh, yeah.
To evaluate those facial recognition attacks.
Right.
It wasn't just about, those cold, hard metrics. It was like, hey, let's bring in the human element here.
Right,
Have real people assess the recognizability of these images.
Yeah, that's what I found so compelling about it as well. It really kind of humanizes the research.
Right.
It reminds us that, ultimately this is about people.
Right.
This is about protecting individuals' privacy, their dignity, their sense of self.
Right.
And, it's about ensuring that this powerful technology is used in a way that benefits humanity and doesn't exploit it.
It grounds it.
Right, yeah.
In the real world.
Right.
It's like behind all these algorithms and data sets are real human faces and real human lives. And we have a responsibility to protect those.
Yeah, it's a potent reminder that, AI research isn't just a purely technical pursuit, right?
Right.
It's intertwined with social and ethical and even philosophical considerations, and we need to kind of approach it with this holistic perspective.
Right.
Recognizing that it has the potential to shape society in very profound ways.
And that brings us to like the bigger point, right? They looked at decision trees.
Right.
They looked at neural networks for facial recognition, but what about all the other types of models out there? Are there hidden vulnerabilities that we haven't even thought about yet?
Yeah, I mean, that's a question that kind of keeps me up at night, right?
Right.
Is as models become increasingly complex, especially with the advent of deep learning, where you have these massive, interconnected networks, the potential attack surface expands exponentially.
Right.
And we're constantly playing catch up, trying to understand and mitigate these vulnerabilities as they emerge.
It's like we're exploring uncharted territory, right?
Yeah.
We're excited about the possibilities.
Yeah.
But we also have to be aware of the potential dangers.
Precisely. Yeah. I think we need to cultivate a culture of healthy skepticism within the research community.
Right.
Constantly questioning our assumptions, probing for weaknesses,
right,
pushing the boundaries of our understanding, because complacency is the enemy of progress,
right,
especially in a field as dynamic as machine learning.
So to wrap things up here, what's the big question that we should leave the listener with? What's the next frontier in this exploration?
Well, I think the most pressing question is, how do we build a future where AI empowers us without exploiting us? How do we harness this immense potential while also safeguarding, individual privacy and autonomy?
Right.
This paper has illuminated some of the challenges.
Right.
But it's really just the tip of the iceberg, right?
Yeah.
And we need a collective effort from, researchers, developers, policymakers, and even the general public to really navigate this complex landscape.
It's call to action.
It is. Yeah.
Right. It's not preordained. This is something that we are shaping through the choices we make through our research.
Yeah, sure.
Through the values that we embed into these technologies.
Right.
And we have a responsibility to do it wisely.
Absolutely. Yeah, this paper has given us a lot to ponder, and I hope it sparks, further research and innovation and thoughtful discussion within the community.
Right.
We need to keep pushing the boundaries of knowledge while always remembering the human impact of our work.
That's great. Yeah. And thanks for joining us. This has been a fascinating deep dive.
Yeah, my pleasure. And it reminds us that AI research, it's not just a purely technical pursuit, right? It's intertwined with social and ethical and even philosophical considerations, and we need to approach it kind of holistically, recognizing that it has the potential to shape society in very profound ways.
And that brings us to the bigger point, right? They looked at decision trees, they looked at neural networks for facial recognition.
Right.
But what about all the other types of models out there?
Right.
Are there hidden vulnerabilities we haven't even thought about yet?
Yeah, I mean, that's the question that keeps me up at night. As models become more and more complex, especially with deep learning, these massive interconnected networks, the potential attack surface is just expanding exponentially.
Right.
And we're constantly playing catch-up, trying to understand and mitigate vulnerabilities as they emerge.
It's like we're exploring uncharted territory, we're excited by the possibilities, but we also have to be aware of the potential dangers.
Precisely. And I think we need to cultivate a culture of healthy skepticism.
Right.
Within the research community, constantly questioning our assumptions, probing for weaknesses, pushing the boundaries of our understanding, because complacency is the enemy of progress, especially in a field as dynamic as machine learning.
So to wrap things up here, what's the big question that we should leave the listener with? What's the next frontier in this exploration?
I think the most pressing question is, how do we build a future where AI empowers us without exploiting us? How do we harness this immense potential while also safeguarding individual privacy and autonomy?
Right.
And this paper has illuminated some of the challenges, but it's really just the tip of the iceberg.
Right.
We need a collective effort from researchers, developers, policymakers, even the general public to navigate this complex landscape.
It's a call to action.
Right.
This isn't preordained. This is something that we are shaping through the choices we make, the research that we do, the values that we embed into these technologies.
Yeah, exactly.
And we have a responsibility to do it wisely.
Absolutely. This paper has given us a lot to ponder, and I hope it sparks further research and innovation and thoughtful discussion. And we need to keep pushing the boundaries of knowledge while always remembering the human impact of our work.
That's a great point to end on. This has been a really fascinating deep dive.
Yeah, it's been a pleasure.
I really appreciate you being here. Thank you.
Thanks for having me.